Picking up where we left off talking about samples and populations and bias questions and all this information, we were just about to talk about bias questions. So not only can samples be biased where the sample is not reflective of the population, but it is also possible that the question that is being asked can be biased. One example of this would be if the question was a leading question. So the question was stated in such a way that you wanted to agree with the surveyor. For example, if I said a question that was like, "Don't you think my dog is the cutest dog in the world?" That's pushing my opinion onto you. So even if I had gotten a perfect sample and I had randomly selected 10 people to ask people if my dog was the cutest dog ever, well, that question is still going to be biased because, if I say, "Don't you agree?" Well, that's biased. I'm implying that I want you to agree with me. Another way that we could have a biased question would be if I asked something like, "Do you prefer the fun of shopping in stores or the convenience of shopping online?" So what's wrong with that question is I've used adjectives in the question itself to kind of sway the opinions of the person who is answering the question. Why that is wrong is I'm stating my opinion. If the surveyor says, "Hey, don't you prefer the fun of shopping in stores?" Well, there are plenty of people who do not think shopping in stores is fun. And quite frankly, there's plenty of people who don't think shopping online is easy either. My grandma would not know where to even begin to try shopping online. And so for me to state that question when there's opinions involved could sway the responder. They might just be like, "Well, I prefer fun over convenience, so I'm going to pick the one that's fun," or just there's too much distracting from the actual content of the question. The last term that I want to talk about is the margin of error, and in this time, you guys, like, at least for me, I was reading an article this morning talking about coronavirus, and they were talking about how the margin of error it was a sample of a certain number of people, and they're like, "This is what the margin of error is." And so, when you conduct a survey and you ask a certain number of people, depending on how many people you ask, you're going to have something called the margin of error. And what the margin of error is, we're saying, "Hey, we don't have the ability to ask everybody in the population, right? Ideally, sure, we'd love to ask everybody in the population, but we don't. So we actually ask the sample, which is that small subgroup of people. Our sample isn't necessarily going to be a perfect reflection of the population. There is going to be a little bit of error there. And this margin of error gives us a range where we expect our findings of our sample to be within that percentage of the actual population. You guys, this is going to be your calculation that you have to do. It's the only calculation in the whole section. So the margin of error is equal to plus or minus 1 over the square root of n. And then you are going to have to convert this into a percentage. Like I said, the actual math involved here isn't all that difficult, but so here's the premise. Let's say that we asked 2,000 people. That's the size of our sample. And I want you guys to be able to calculate the margin of error. Like I said, the margin of error was plus or minus 1 over the square root of n. And so what you're going to do is you're going to take that 2,000 and you're going to plug that in for n. So you're going to do 1 divided by the square root of 2,000. When you type that in your calculator, you should get 0.0224, we'll say. What you're going to have to do is you're going to have to present this in the form of a percentage. So the margin of error is 2.24%. Now, due to the nature of margin of error, we're going to say that it's always going to be plus or minus. And here is the reason for that. Let's say that I ask, let's say that the sample or the population is like, all of North America. And I ask 2,000 people, is my dog the cutest dog in the world? And the number that my sample comes up with of 2,000 people is, let's say 30% of people say, yes, Mr. Nyquist, your dog is the cutest dog in the world. And then you take, you do the margin of error calculation. You say, okay, yes, we didn't get to ask everybody, right? We only asked 2,000 people, but 2,000 people said 30% of people think Mr. Nyquist's dog is the cutest dog in the world. And then we calculated the margin of error and we said, okay, we expect this 30% to be accurate within plus or minus 2.24%. So there might actually be 2.24% more than 30% of people who think my dog is actually the cutest dog in the world, or 2.24% less than 30%, but it's going to be somewhere within that range. That's what our margin of error is. This is an approximation. This is what 2,000 people said. All people in North America are going to be within 2.24% of that 30%. So I could ask you guys for an interval. And what you would do is you would add 2.24 to 30, and you would get 32.24%. That's in the high range of people who think my dog is the cutest dog in the world. And then you'd have to do 30 minus 2.24%. And that would tell you 27.76%. So there's somewhere between 27.76% and 32.24% of people in North America who think my dog is the cutest dog in the world. If, when I conducted a survey, a sample of 2,000 people, and 30% of them said yes, the actual population, the actual all people in North America, are going to be somewhere within that range. For this formula, you guys are also going to be expected, I'm going to skip this one again, you guys are going to be expected to go the other way with this. So if you have a margin of error of 4.2%, you guys should be able to calculate how many people you would have to ask to get that margin of error. We're going to really kind of do this process in reverse. So the last thing that we did was we converted 4.2% into a decimal, or we converted 0.042 into 4.2. Now I'm going to convert that back. So it'll be 0.042. And that, of course, is equal to, because we have the formula, 1 over the square root of n, right? We said margin of error is 1 over the square root of n. Now we're just going to solve for n. Now, this isn't an extremely easy thing to do because I think people just run into errors when they try this. Our goal is to solve for n, and we have a fraction here, and over here we have a decimal. We can pretty easily convert this into a fraction equal to a fraction situation by doing over 1. And then I'm just going to cross multiply. So I'm going to multiply these two by each other. Well, 1 times 1 is just 1. That's pretty easy. And cross multiplying those two by each other, you'd have 0.042 root n, just right next to each other. Now I have a pretty easy equation to solve. I'm going to divide both sides by 0.042. By 0.042. 1 divided by 0.042 is 23.81. About. And I'm going to square each side. Squaring that number gives me 566.89. I'm just going to round that to the nearest person. 567 people is how many I would need to ask to get a margin of error of 4.2%. So all of this is what you guys need to know for 11.4. Make sure you try these examples and you know how to do it. Good luck, and remember to check into office hours if you guys have any questions.